There have been a lot of headlines lately about the Christmas star, or the Star of Bethlehem, being visible on December 21st, which is the winter solstice in the Northern Hemisphere. But what does this mean? What the headlines are referring to is the great conjunction of Jupiter and Saturn as seen from Earth. Over the past several months, our view from Earth of the two planets shows them getting closer and closer together, such that the pair will appear to become a single source of light on the 21st of December. This has more to do with Earth's movement or orbit around the Sun and less to do with how much Jupiter and Saturn are actually moving. On the 21st, the Earth will have caught up to a place in our orbit where Jupiter and Saturn are aligned from our point of view. After the 21st, the pair will appear to separate until we can no longer see them as they will be blocked by the glare of our Sun. While the media has broadcast this as a rare event, the orbital resonance of Jupiter and Saturn resulting in the pair appearing close together from Earth's perspective happens about every 20 years. However, what's so special about this conjunction in 2020 is just how close they are at only 6.1 arc minutes apart, or about 1/10 of a degree. The last time they were this close was July of 1623, but it's doubtful this was observed. By the time the Sun set low enough below the horizon, the pair would only have been 3 degrees above the horizon. Very difficult to see. In August of 1563, the pair would have been about as close as they appeared on the 21st of 2020, but higher in the pre-dawn sky, just above the Beehive cluster and the bright morning star Venus. If we go back to 1793 BC, that conjunction was 4 times closer than the 2020 conjunction, higher in the sky and accompanied by a waning crescent moon and the planet Venus around 3 a.m. However, the closest conjunction in almost 14,000 years will occur in the 46th century on March 8, 4523 in the early morning, but the pair will be very low on the horizon. Here are some photos that I took of Jupiter and Saturn in the weeks leading up to the conjunction. The landscape photos were all taken with my iPhone. The December North Carolina weather did not always afford me an opportunity to take some pictures, so you may notice some gaps in the dates. I also managed to snap a few pictures through my 4-inch refractor and a 21mm eyepiece using my iPhone. This is called afocal projection. Here's a quick sequence of pictures I was able to take of each night's progress through the telescope. On the evening of the Great Conjunction, my observing buddy and fellow NASA JPL Solar System ambassador set up atop a local parking deck to live stream views for a program we supported with the Moorhead Planetarium and Science Center. Unfortunately, lots of other people had the same idea in going to the top of the parking deck. With lots of cars driving past, as well as people walking past, the telescope mounts were constantly shaking and resulted in very poor views. Here you can see the pair shaking all over the screen, to the point we couldn't even get good focus. You can definitely tell when a car drives past. We were disappointed in the quality of the results from the 21st. However, the next evening provided another opportunity, and we set up in the parking lot with a view of the low southwestern sky. Although not as close as on the 21st, Jupiter and Saturn were still only 10 minutes and 13 seconds apart from each other, or 0.17 degrees. To put that into perspective, 0.17 degrees in the sky is the same distance as the thickness of 2 dimes held at arm's length. Just look at how steady the picture is. No more setting up on top of parking decks for me. This particular video is set to expose just the details of Jupiter. You'll notice that Saturn is very dim and you can't see any of Jupiter's moons. It's hard to grasp the actual distances between Jupiter, Saturn, the Earth, and the Sun. But if we put it into the perspective of the speed of light, it might help. In the case of Jupiter, the light we're capturing here in this image first left the Sun and traveled 474 million miles, which took approximately 42 minutes and 25 seconds. From there, the light is reflected back to Earth, a distance of 574 million miles, which took another 48 minutes and 53 seconds. The total from the Sun to Jupiter and then to Earth was about 1 billion miles and took 1 hour and 48 minutes and 54 seconds. In this video capture, I've set the exposure so that we can see the details of Saturn and its rings, as well as the moons of Jupiter. However, Jupiter is overexposed and none of the planet's features are visible. Just like I explained for Jupiter, the distances to Saturn are also hard to grasp. With Saturn, the light we're capturing here in this image first left the Sun and traveled 928 million miles to Saturn, which took 1 hour and 23 minutes. From there, the light is reflected back to Earth, a distance of 994 million miles, which took 1 hour and 29 minutes. The total from the Sun to Saturn to Earth was 1.9 billion miles and took 2 hours and 52 minutes. Here we have the final product, stacking images from each of the 2 separate videos and then merging them together.